Okay, I got a question from a student. They're having a little bit of difficulty with prime numbers, so let's talk about it for a moment. Let's talk about what a prime number is. A prime number is a number that is only evenly divisible by itself and 1, or another way to say it, that it can only be created when you multiply 1 by itself. For example, 2 is a prime number, so is 11, and 3, and 7, and 29 is prime, and I believe 37 would be a prime number. These are examples of prime numbers, okay? So, what you want to do when we're talking about writing numbers in their prime factors or factoring a number into its prime numbers, what that means is that we're going to break the number down as far as we can until we can't break it down anymore, writing each of the individual pieces or factors, I should say, as a multiplication problem. So, for example, let's look at two examples. We're going to look at 24 first of all. And what you want to do is, first of all, ask yourself, what two numbers do I know that I can multiply together to give me 24? And it doesn't have to be any particular pair. You can pick any pair of numbers that you know that give you 24 that you choose to. So I'm going to choose 4 and 6. So just note that you could have also utilized 2 and 12. You could have used 3 and 8. Did you get the idea? So it doesn't matter, you're going to get the same results. So I am creating a factor tree here. So once I am at this level, right, I am now going to ask myself, okay, can I break any of those numbers down any further? So the answer, of course, is yes. Here, the 4 is created by taking 2 times 2. And then we're going to multiply that by the breakdown, if you will, of 6, which is 2 times 3. Okay, that's a multiplication sign. I promise that's a multiplication sign. Okay, so if you notice the shape that we have here, it's kind of like a tree, hence the word, the factor tree, right? So this factor tree, once you have completed the factor tree, what you end up with here at the base is the prime factorization of the number you began with, which is 24. Okay, so the base of your tree are your prime factors. Notice none of these numbers can we break down anymore. If we tried to break it down, the only thing we would result in would be 1 times itself, right? So these are our prime factors for 24. Let's take a look at another number. Let's look at a big one. Let's look at something like, let's look at 144. Okay, so we're going to look at 144 for a moment and make a little division line there. So what two numbers do we know that when we multiply together we get 144? What's one pair, what's a pair of factors for 144? I'm sorry, I'm stumbling over my tongue tonight. Well, we learned a long time ago that 12 times 12 is 144, right? So at this stage, we ask ourselves, well, can I break these numbers down any further? And the answer to the question is yes. I can break 12 down into 3 times 4. And just to prove to you that it doesn't matter, I'm going to use 2 times 6 on this side. Okay? So now, here at this stage, we will ask ourselves again, can I break any of these down any further? Well, for 3, the answer is no. So what we're going to do is just bring the 3 down because we want the base of our tree to be solid, right? So we don't want to forget anything. So bring your 3 down. The 4 can be broken down further into 2 times 2. And the 2, can we break that down? Well, the answer there is no. So we just bring it straight down. All right, it just falls down further to the base of the tree. And the 6 will break down into 2 times 3. So there you have it. We have factored 144 in its prime factors. Again, the base of your tree are the prime factors for the top of the tree, right? The star at the top. So I hope this information helps you. If you have any further questions, please feel free to contact me. Thanks and have a great evening.